Every day, we see patterns in the world around us. They testify to the careful design and hard work that produced them. But what about the patterns that are not made by man, but appear in the natural world? What do they reveal? Consider the snowflake. These tiny crystals are formed when water vapor in a cloud condenses directly into ice. As the crystals grow, delicate and beautiful patterns emerge. Look more closely at the pattern within a single snowflake. The crystalline arms branch, then branch again and again at increasingly smaller sizes. Mathematicians studying this concept of self-similarity use the term fractal to describe a shape that has a consistent, repeated pattern at multiple scales. Where else can fractal patterns be seen in the natural world? Trees can demonstrate a degree of self-similarity. The trunk splits into limbs, which split into branches, then twigs, and so on. We see a similar type of fractal pattern in the leaves of a fern. A different type of pattern, but one that is also a fractal, can be seen in the shell of the chambered nautilus. As it grows, the nautilus builds new, larger chambers and seals off the older, smaller ones that it no longer needs. The result is a spiral that is fractal in nature, maintaining a similar shape as it increases in size. Natural spiral patterns of this type can be observed in many places, from the cloud formations of a hurricane to tiny shells on the beach, from the arrangement of the stars in a galaxy to the seeds on a sunflower head. What causes these spiral patterns? In the case of the sunflower, it has to do with the specific angle at which new plant growths form. This angle, approximately 137.5 degrees, is sometimes called the golden angle. It results in an ideally compact arrangement with no wasted space and creates distinct spiral patterns. If the sunflower grew not at the golden angle, but at a different angle, for example 140 degrees, we would see radial arms instead, and the seed arrangement would not be as efficient. As we look even closer, we can discern a fascinating mathematical relationship between this golden angle and a series of numbers called the Fibonacci sequence. In this progression, each number is determined by adding the previous two numbers together. Interestingly, these Fibonacci numbers can often be observed in plants. This sunflower has 34 spirals in one direction and 55 going the other way. Both of these numbers are in the Fibonacci sequence. A pineapple will often have 8 or 13 spirals. Flowers with a spiral growth pattern tend to have a Fibonacci number of petals. Why are these numbers significant? As the Fibonacci sequence progresses, the relationship between successive numbers comes closer and closer to defining the exact value of the golden angle. This intriguing mathematical relationship between the golden angle of plant growth and the number of resulting spirals reminds us that the patterns we see in the natural world are not merely accidental. Each one is a reflection of order and careful design. As we take time to examine these patterns more closely, we're filled with a sense of wonder at the workmanship of their designer, Jehovah God. For His invisible qualities are clearly seen from the world's creation onward, because they are perceived by the things made.